The alternative to practical you just concluded Waec GC Series 1 2024. So we look at the question says in an acid-base titration, 25.0 cm³ of a solution of sodium hydroxide containing 1.50 gram in 250 cm³ of solution required 15.15 cm³ of a dibasic acid H2I for complete neutralization. So the equations of the reaction is given. NH2I plus 2NaOH gives us Na2Y plus 2H2O. So we have the question also said that we should do what? Calculate 1. The concentration of sodium hydroxide solution in mole per dm³. Number 2. The concentration of dibasic acid solution in mole per dm³. Also, number of hydrogen ion in 1.0 dm³ of the acid solution, the volume of distilled water that should be added to 25.0 cm³ of the acid solution in order to dilute is twice. So let us look at the question. In this type of exam, students are not allowed to perform experiments because an alternative to practical. So all those parameters that you're going to need has been given unto them in this word. In this question, we're going to be picking them out one after the other. Now, the question one said, calculate the concentration of sodium hydroxide solution in what? In mole per dm³. So this is, we are being given 1.50 gram in 250 cm³. The meaning of the implication of this thing is that 1.50 gram of sodium hydroxide dissolved in what? In 250 cm³ of the solution. So what we are going to do, we must convert this one to what? To gram per dm. So it's of two ways. So let us see. 1.50 gram of NaOH dissolved in 250 cm³. Now, what will be in gram of the same NaOH that will dissolved in 1000 cm³? So let us see. So when we cross multiply, we have 1.50 times 1000 all over 250. 250 here 1, 250 here 4. So we have 1.50 multiplied by 4. So 1.50 multiplied by 4 will give us 1.50 multiplied by 4. What will it give us? It will give us 6 gram. 6 gram per what? Per dm³ now. So we can now use our formula to calculate the concentration in mole per dm³. Now we can now use number of mole is equal to mass given all over molar mass. So we have, what is the mass given to us? Our mass is equal to 6. Okay? And we are looking for the molar mass of sodium hydroxide. So let us see. Sodium hydroxide, which is, sodium is 23. 23 plus oxygen is 16 here, plus 1. So everything is what? Is 40. No? All this one, sodium is 23, the atomic mass of sodium is 23, the atomic mass of oxygen is 16, and hydrogen is what? Is 1. So just substitute for this formula, which is 6 all over 40. What are we going to get? 6 divided by 40. We have divided by 40, we have 0.15 mole per dm³. That is the first method, way in which you can use to solve this equation. Now, another method I can use is, okay, alternatively, I'm still talking about that number one. Alternative, you can say, okay, we are given the mass. So let us start the mass. Let's find the number of mole first. Number of mole is equal to mass all over molar mass. So since we've gotten the mass, the molar mass of NaOH, we don't need to do what? To find it again. So what we just do that, what is our mass? Here given to us is 1.50 gram all over molar mass of sodium hydroxide is 40. So we have 1.50 divided by 40. We have 0.0375, which is mole. It's not yet a mole per dm cube, it's a mole. So this one is a mole. So we have, so it's a mole. So now we can now convert this. So this one means that the implication of this is that 0.0375 mole of NaOH dissolves in 250 centimeter cube. Okay? So now what will be the mole? X this one of NaOH that will be dissolved in 1000 centimeter cube. So cross multiply 0.0375 times 1000 all over 250. So what do we have there? Times 1000 is equal to 37.5 divided by 250 divided by 250, which is equal to, we still have 0.15 mole, which is equal to 0.155 mole per dm cube. So any method you want to use, probably you want to calculate, convert it to gram per dm cube first before you use the number of moles equal to mass and molar mass, or you want to convert it to what? To mole, using the number of moles equal to molar mass before you convert it to what? To mole per dm cube. Everything is what? Is accepted. So just that you know the procedure that follows. So number one has been settled. Now, number two. Number two says, now the concentration of diabasic acid solution in mole per dm cube. So let us go back. So that's why I'm going to use our CaVa all over Na is equal to CbVb all over Nb. As I used to tell my students that it's better that you list out the parameters so that you know which one they're being given. So let us see. Our Ca, concentration of acid, is unknown. We are looking for it. The volume of acid, which is our titer value, have been given unto us required, that is 15.15 centimeter cube. And our Na is taken from our what? From our reactions, from our chemical reaction. Our Na is taken from here. So we have, what we have here is what? The number of mole of acid that is reacting, which is 1, is equal to 1. Our Nb, that is what? The number of mole of base that is reacting, which is equal to 2. Now what about Cb? Our Cb is one that we just calculated there, which is 0.15 mole per dm cube. And what about our Vb, the volume of base, this one, which is 25.0 centimeter cube. So what are we looking for? We are looking for our concentration of the diabasic. So let us make Ca the subject of the formula. So we have, when we cross multiply, CaVa, when we have Ca all over Na is equal to CbVb all over Nb. So we cross multiply. CaVa Nb is equal to CbVb Na. So this one, our Ca will now be divided by what? Our Ca is equal to CbVb Na all over Va N what? Nb. So let us substitute. Let's substitute. So our Cb is equal to what? 0.15 times our Vb. Our Vb is given as 25. Our Na, which is 1, all over our Va, which is 15.15. Our Nb, which is equal to 2. So what do we have here? We have, so 0.15 times 25 times 1 is equal to 3.75 all over 15.15 times 2, which is equal to 30.3. So we now have 3.75 divided by 30.3. What we have? We have 0.1212 mole per 0.12, which is equal to 0.12 mole per gm cube. That is what? That is our answer. Let's check it again. Our CB is 0.15. Our VB is 25. Our NA is 1. And what about our VA, which is 15.5? Our NB, which is 2. So I think we get the right answer. So now let's go to the question number 3. It said, question number 3 says, we should calculate the what? The number of hydrogen ion in 1.0 gm cube of acid solution. So don't let us forget that 1.0 gm cube of what? Of A, of solution A, is this one that we obtained, 0.12 mole. Okay, 0.12 mole. And don't forget that when this dialysic acid ionize in water, they have, this is H2Y. When they ionize in water, you have 2H plus Y minus. That one is telling us that 1 mole of dialysic acid, which is H2Y, that's 1 mole of dialysic acid H2Y. What did it do? It gives us what? It gives 2 mole of hydrogen ion. So now, what will have, this one will now give us what? How many hydrogen ion concentration will this one give us? 0.12 mole of H2Y gives X. So when we cross multiply, so we have 0.12 times 2, which must give us 0.12 times 2 must be what? 0.12 times 2 is equal to what? 0.24 mole. That's yeah, not stop. So we are still continuing this. So it means that 0.24 mole. 2.4 mole. So 0.24 mole. And don't forget that 1 mole of hydrogen ion is equal to 6.02 times 10 to the power 24. That is Avogadro constant. Now, when 1 mole of atoms at Avogadro constant is 6.02, so what will the mole of 0.24 mole of hydrogen ion give to us? 0.24 mole of hydrogen ion is equal to X. So we have 0.24 times 6.02 times 10 to the power 24. So what do we have here? 0.24 times 6.02 exponential 24. So what we have here? We have 1.44 times 10 to the power of 20 watts. 24 watts ions. 24 ions. So that is what we have here. Now, the last question it said, said, now volume of distilled water that should be added to is 25.0 cm³ of the acid solution in order to dilute it twice. Volume of water that should be added. Okay, let me just check this question again. 2.4 times 10 to the power minus 1 times 6.02 times 10 to the power 24. 2.4 times 6.02 times 10 to the power 24 minus 1. So we have 2.4. My mind is telling me that this calculator is not giving me what it's supposed to give me. 2.4 times 6.02 is equal to what? That is equal to 1. This is what? 14.4